Okay, I can just include one more page. So these are all the problems today we are going to discuss, and better we can just recall the formulas. It's very, very important. Brother, in this chapter, the most important thing is the wave equation. If you know the wave equation, you can easily get the information. Understand? So what is your wave equation? The displacement of the wave equation, x of t, which is equal to xm cosine of omega t plus phase angle phi. Am I right? Am I right or not?
Yes.
Okay. What is the equation for velocity? If you differentiate this equation one time, you will get the velocity equation v of t, which is equal to minus omega xm sine of omega t plus phi. If you want to find the magnitude of the velocity, maximum speed, the maximum speed which is given by omega multiplied by xm, and then acceleration of the equation. What is our acceleration of the equation? If you differentiate this equation one more time, you will get the acceleration which is equal to minus omega square xm cosine of omega t plus angle phi. So what is the maximum acceleration? The maximum acceleration which is equal to omega square xm. We studied this equation. And then what is the formula for finding the frequency? Frequency which is equal to 1 over time period. What is the formula for the relation between angular frequency and the linear frequency? Omega, which is equal to 2 pi f. If you take this and substitute here, you will get 2 pi over t. So this is also omega. And then simple harmonic motion, Hooke's law. So if you are just having the mass along with the spring, if the spring produces simple harmonic motion, we have the rule of omega. Am I right? Omega, which is equal to square root of k over m. And then time period for the simple harmonic motion for the mass with the spring, time period t, which is equal to 2 pi square root of m over k. Likewise, simple harmonic motion for the simple pendulum, omega, which is equal to, because simple pendulum also we studied. Am I right? Am I right or not?
Yes.
So what is your omega? Omega, which is equal to square root of g over L, and the time period for the simple pendulum is 2 pi square root of L over g. And then we studied the equation for the conservation of mechanical energy. That means the energy equation, which is equal to potential energy plus kinetic energy, which is nothing but half k amplitude square, potential energy formula half k x square, kinetic energy formula half m v square. So this is the formula we are going to find the energy equation. So these two are equal to this one. So please read the question. What is given in the question? You have to identify what is given, and after that you have to substitute the formula, substitute the value in the formula to get the final answer. Understand? Clear?
Clear, doctor.
Okay. First question. It's very, very easiest question. First of all, read and first know what is given. An oscillator. Oscillator means it's a simple harmonic motion. Whatever the problem we are going to solve from this chapter, it's an oscillator. What is my oscillation? It's produce some sine or cosine wave. That means waveform will be there. Once the waveform will be there, it must have the time period. It must have the frequency. It must have the angular frequency. It must have a spring constant. Suppose if the question is related with the spring mass system, then for sure it has some spring constant K, and it has some maximum speed. It has some maximum force. So whatever the question from this chapter is related with the simple harmonic motion. So we just read what is given. An oscillator consists of a block of mass 0.5 kilogram is connected to the spring. That means a spring mass system. So you attach one end of the spring to one end, and another end of the spring you attach the mass, and that mass is given as 0. That means the block of mass is 0.5 kilogram. So I can write the mass. What is our mass? Mass which is equal to 0.5 kilogram. When set into oscillation with an amplitude of 35 centimeters, what is your amplitude? My amplitude xm, which is equal to 35 centimeter. If you converted this into meter, 35 multiplied by 10 to the power of minus 2 meter. And this oscillator repeats its motion every 0.35 seconds. That means continuously. That means its time period is given. Am I right? So for example, if the oscillator is oscillating every, it will be repeat 0.35 second for every motion. Okay, so that means how much time for one complete wave? They are just giving the value 0.350 second. First question, find the period. What's the value? What's the answer for the first question? Find the period. What is your period, my dear? What is period? Our period is T. Am I right? Am I right or not?
Yes.
So they clearly mention what they mentioned here. You can just read the question. The oscillator repeats its motion every 0.35 seconds. So if it repeats every 0.35 seconds, it is nothing but your time period. Am I right? So I can just write the motion repeats. The oscillator motion repeats every 0.35 second. So its time period is also. So its time period is also 0.35 seconds. Clear? So from the question itself, the answer for the first question is there. Now, the most important thing, the answer starts from the second part. What is your second part? You have to find the frequency. My dear, what is the formula for frequency? Because this is your T, am I right? This is your T. We have the formula. What is your frequency?
1 over T.
1 over T.
So we have the formula frequency, which is equal to 1 over T. Take this value and substitute here. You will get the answer. Am I right?
Yes.
Okay. What is your third question? Angular frequency. So your angular frequency is omega. So what is the formula for angular frequency, my dear? Angular frequency, we have two formulas, but here we already have the time period. I can use this. Am I right?
Yes.
So 2 pi over T. So T is here. I can just directly substitute. Or if you want to use this, you can just use 2 pi f. Both are right. Okay. So if you write this formula, you have to take the answer and substitute here. Clear? Or if you want to use this formula, take the time period, substitute here. You will get the same answer. Understand?
Yes. Yes.
Okay. What is the answer for the third one? Sorry, fourth one. Finding the spring constant. My dear, we know the formula because they clearly mentioned what they mentioned. Just read the question. A mass is connected to a spring. That means you can just go back. You can just go back to the spring. So this is the slide. Am I right? So you have the mass connected with the spring. So by using this concept, we have to find the spring constant, and we know the formula F is equal to minus Ks. Am I right? But in the question, there is no information about the force. There is no information about the X. Am I right?
Yes.
But we have this rule. Am I right or not? But we have this rule. What is this? Omega, which is equal to square root of K over M. So I can use this because this is my spring constant. This is my mass. This is my angular frequency. I can use this for the system. Am I right?
Yes.
Am I right? So
Doctor,
if you want to, yes, my dear.
we have
Yes.
X
Where we have X?
information.
Where we have X? That is amplitude. X is the displacement. Xm is the amplitude. Don't get confused.
Okay,
My
what's the
dear,
difference?
X is the displacement, xm is the amplitude. Don't get confused about these two. Displacement, for example, if you have the spring, when you connected the mass, how much it is displaced? Once you attach the mass, what will happen? Your spring will be coming like this. Am I right?
Yes, you're right.
So this is your x,
Ah, okay, okay.
but
This
x naught is
it's
the maximum.
amplitude.
For example, this is your xm. Clear?
Clear, clear.
So I can use this formula, my d part, which is equal to omega, which is equal to square root of k over m, but I just want to find the value of k, so I can just squaring left hand side and right hand side, I will get omega square, which is equal to k over m. Therefore, my k, which is equal to omega
Omega
square
square m.
multiplied by m. So now you can see we have the omega value in part C. We have the mass in the question. When you substitute, you can easily find the value of k. Am I right?
Yes.
Clear? It's a very easiest question. But my dear, listen carefully. If you made a mistake in the first question, all the remaining questions answer will be wrong. So please do it very carefully. Especially in this chapter, we can ask the question like this, because one question, the answer of the first question, you are going to substitute the second question. The answer of the second question, you are going to substitute the third part. So please do it very carefully. Use your calculator very carefully. Understand?
Yes.
Okay. So this is the answer for D part. What is the answer for E part? Maximum speed. My dear, what is the formula for maximum speed? This is the formula for the maximum speed. Am I right?
Yes. Yes.
So I can just use the formula E, which is equal to, this is my fifth question. What is the formula? Vm, that means V maximum, which is equal to omega multiplied by xm. Omega, we already got from part C, am I right? And xm, it is already given in the question as 35 centimeter. So when you substitute, you will get the answer for the E part. Am I right? Am I right?
Right.
Yes.
Oh, yes. Any question? Is it
No,
clear?
clear.
Okay. What is the answer for the last question? They clearly mentioned find the magnitude of the maximum force. My dear, here we know the Hooke's law. What is our Hooke's law? F is equal to minus kx. X is the displacement, but what they mention here, we are going to find the maximum force based on the amplitude. So I can just write these as minus kxm. Am I right?
Yes.
So from this, I can just take the magnitude, because they clearly mentioned the word magnitude. So I can just take only the magnitude. So the force which is equal to positive becomes negative, so negative become positive, k of xm, and the k part I can just take from the answer of D. I can substitute here. Xm is already given in the question. When you substitute, you will get the answer for the F question. All right? F question. Am I right?
Yes.
Right.
Clear?
Yes.
Clear.
Any question from your side? My dear, any question from
Doctor,
your
no.
side? Yes.
No. When he wanted the maximum force, I changed it from x displacement to x amplitude.
Because either you can work out with the x naught, either you can work out with the xm. Because your x naught is the maximum displacement, xm is the amplitude. Am I right? Wherever you got the maximum displacement, you will get the amplitude. Am I right?
Yes.
So I can use xm here, no problem.
Okay.
Clear?
Clear, doctor.
Okay. So answer is given here. Please take practice. The second question, again, spring mass system. That means the block spring system, and it producing some oscillation. They clearly mentioned an oscillating block spring system has the mechanical energy. My dear, mechanical energy E. I can just take mechanical energy as my E. So we already know what is the relation for mechanical system, brother. What is law of conservation of mechanical energy? The law of conservation of mechanical energy says it's a total mechanical energy which is equal to potential energy plus kinetic energy. Am I right?
Yes.
Okay, so now you can just see here, I have the mechanical energy. The value of the mechanical energy is given as 1 joule, and it produces an amplitude xm value as 10 centimeter. So I can convert it to meter, 10 to the power of minus 2 meter, and it has the maximum speed. So the maximum speed V is given as 1.2 meter per second. Now what we are going to do, we are going to find the first question, we are going to find the spring constant K. In the second question, we are going to find what should be the mass, and then third question, we are going to find the frequency. My dear, the question again, it is related with the block spring system. Block spring system, you should be very, very careful. So we have the formula for frequency also. So we just start from the first question. My dear, you can just see here, we already have this formula. What is our energy formula, my dear? What is our energy formula? Our energy formula, which is equal to?
Potential energy plus kinetic energy.
Which is equal to half k xm square. Am I right?
Right.
So I can use this formula here to find the answer for the first question. What is our first question? My A, which is equal to my energy, which is equal to half k xm square. And from this, I can find the value of k. You can just rearrange the question. K, which is equal to 2 multiplied by energy divided by xm square. Am I right? Am I right?
Yes, you are right.
Now you can see energy value is given. What is the value of energy? It is already given in the question, 1 joules. What is the value of amplitude? Amplitude is given as 10 centimeter. When you substitute, you will get the answer for the spring constant. Am I right?
Yes.
Okay, what is your second question? We know the rule, my dear. We know the rule. This is our rule. Am I right? So now my energy, which is equal to potential energy plus kinetic energy, my dear, if you want to find the block's mass, we already have the maximum speed. Am I right? Am I right?
Right. Yes, you're right.
When the object has the maximum speed, what should be the potential energy? It will be 0. Am I right?
Right.
So I can write E, which is equal to my kinetic energy. What is the formula for kinetic energy? Half mv square. Am I right?
Yes, yes.
Am I right or not? So
right.
I can just, from this formula, I can find the mass. Therefore, my mass, which is equal to 2 multiplied by energy divided by v square. Am I right? Energy is given in the question. Your maximum speed is given in the question. You can easily find the mass. Am I right?
Yes, you're right.
Clear? Clear?
Clear, clear.
Okay, what is your third question? We are going to find the frequency. My dear, what is the time period for this block spring system? Just go back. What is the time period for the block system? This is the formula. Am I right? Am I right?
Yes, you're right.
Yes, you're right.
So, and we know the frequency. What is the formula for frequency? My formula for frequency is nothing but 1 over time period. Am I right?
Yes.
And this question is related with the block spring system. So this is my T. When you substitute the T here, you will get the frequency. Am I right?
Yes, you're right.
Yes.
So I can just use this formula. We already know the formula for time period. The formula for the time period T, which is equal to, what is the formula for time period? T, which is equal to 2 pi square root of mass over K. Am I right? Therefore, my frequency, which is equal to 1 over T, so I can take this T, I can substitute here. Therefore, F, which is equal to 1 over 2 pi square root of M over K. Now you can see we have the mass in the question. So sorry, in the B part, we already find the mass. In the A part, we find the K, and pi value is 3.14. When you substitute, you will get the answer for the third question. Am I right?
Yes.
Yes.
What is the unit for the frequency, my dear? The unit for the frequency is
Hertz.
hertz or 1 over second, because the formula is here, this, am I right? So what is the unit? If you substitute 1 over second is the unit, am I right?
Right.
So either you can write hertz or 1 over second. So the unit will be correct. Understand?
Yes, teacher.
Any other question from this? Do you have any other question from this question? If you have any doubt, please ask me.
No, teacher.
Clear? Shall I move to the third one?
Doctor,
Yes.
why in the part A you write energy equal kinetic energy, and in part B energy equal
My dear, part A, where I write the kinetic energy. This is my amplitude square. This is my half mv square. This is the formula, energy which is equal to half. My dear, just before I wrote it here, you can just see this. My energy which is equal to potential energy by plus kinetic energy. Am I right? My energy of the equations depends upon the amplitude. My potential energy depends upon how much it is displaced. My kinetic energy depends on the speed. Am I right?
yes,
So my energy, already we have the formula half k xm square. My potential energy formula is half k x square. My kinetic energy which is equal to half mv square. Am I right?
yes,
So I can directly use this formula for finding the answer of k. Clear?
clear, doctor.
Clear.
Okay. Third question. Question seems like very big, but it's very easy. But please, my dear, first of all, think what is given, because we have only few formulas in this chapter. Let's we just read what is given. A 10-gram particles undergoes simple harmonic motion. What is the meaning for SHM? SHM is nothing but it's a simple harmonic motion which has an amplitude. That means the motion which has some waveform. So the mass of the object is given. What is the mass of the particle? The mass of the particle is given as 10 gram, and it has an amplitude. What is the value of amplitude? Xm value is given as 2 millimeter. So if you converted this 2 millimeter in terms of meter, you will get 2 multiplied by 10 to the power of minus 3 meter, and it has a maximum acceleration, and its acceleration value is given. What is the value of acceleration? 6.5 multiplied by 10 to the power of 3 meter per second square, and an unknown phase constant. But don't worry about that, because they didn't give this value, so don't worry about the angle phi. They just clearly mentioned there is some unknown angle phi. First question, we are going to find the time period. My dear, what is the formula for time period? What is the formula for time period? First question, what we are going to do? We are going to find the time period. Second, we are going to find maximum
Maximum
speed.
speed.
And the third, we are going to find the total mechanical energy. That means the energy which is equal to potential energy plus kinetic energy. And then fourth question, we are going to find maximum displacement. And the fifth question, we are going to find half of the displacement. That means the half of the value of D part gives you the answer of E part. Am I right? Am I right
Yes,
or not?
yes,
Maximum is considered as 1, half is nothing but half of 1. Am I right? So once you find the answer of D, then you can easily find the value of E. So let's we just start from the first question. We are going to find the time period. So what is the formula for time period, my dear? We know the formula for time period from omega, because we know what is omega. Omega, which is equal to 2 pi over T. Am I right?
yes,
Am I right? So I can just take T, which is equal to 2 pi over omega. Am I right?
yes,
But is there any information about omega is given in the question?
no,
But acceleration is given. Am I right?
Yes.
yes,
So what is the rule for maximum acceleration, my dear? Go back to the formula slide. What is the maximum value of the acceleration? My maximum acceleration formula is omega square multiplied by xm. Am I right?
Right.
So I can just directly write here my acceleration maximum is nothing but omega square multiplied by xm, we are going to find this omega. Therefore, I can write omega square, which is equal to a over xm. Am I right?
Yes.
What is omega? Therefore, my omega is nothing but square root of a over xm. Am I right?
Yes.
So I have the acceleration in the question. I have the amplitude in the question. With the help of this, I can find the omega. Am I right?
Yes.
Now take this omega and substitute here. You will get the answer for the first question. Am I right?
Yes.
Okay, let's become for the second question. What is your second question? Maximum speed. My dear, we have the formula for maximum speed. What is the formula for maximum speed? This is the formula for maximum speed. Am I right?
Yes.
Yes.
So I can use this formula here. My maximum speed, which is equal to omega multiplied by xm. It's a direct question. Omega, just before we find it here, take this omega, substitute here. Amplitude is given in the question. You can get the answer for part B. Am I right?
Right.
Yes.
Clear? Understand?
Yes, teacher.
Understand? Okay. Now let's become for third question. We are going to find the total mechanical energy. My dear, my energy equation, just before we use the formula, what is the formula for energy, my dear? What is the formula for energy? You can just see the
Potential.
first part. This is my energy, am I right?
Yes.
So again, I can use this total energy, which is equal to my total energy C, which is equal to E, which is equal to half K xm square. But if I want to find the total energy, my dear, we need the value of K. Am I right? Because without the value of this spring constant, I can't get the total energy. Am I right or not? So what I'm going to do, I'm going to find the energy here, because we already know this question is related with the spring because it's a simple harmonic motion. So we know the rule. What is the rule? Omega square, which is equal to K over M. Am I right? Am I right?
Yes, you're right.
What is this? If you just squaring, what you'll get? Omega square, which is equal to K over M. Am I right? Am I right?
Yes, teacher.
Yes.
So I can use this formula for finding the value of K. So I can just come back to our slide. Our slide is here. So I can just use this formula. Therefore, my K, which is equal to omega square multiplied by mass. I have the omega value here. Take this value, substitute here. I have the mass in the question, 10 gram. So if you just take this value and substitute here, I will get the value of K. Once you get the value of K, take this K and substitute here. Amplitude is already given in the question. You can easily find the total energy. Am I right? Am I right?
Yes.
Clear? Clear?
Clear.
Okay,
Yes.
let's we come for our fourth question. What is our fourth question, my dear? Maximum force. So fourth question, my dear, listen carefully. My fourth question is D. We know the maximum force. F is equal to, I can take the magnitude value. Because it is nothing but K multiplied by xm. Am I right? Am I right or not?
Yes.
Yes.
So here, what is our xm? What is our K? Maximum force. So I can just take the value of K. I can substitute here. Xm is already given in the question. I can get the value of the maximum force. Am I right?
Yes.
Yes.
Okay. Now it's your turn. Could you please tell me the answer for the E part?
The half
Again,
of
I
the
am going
body.
to use the same formula. My dear,
Half
listen
K
carefully.
M.
My dear, half of your amplitude gives you the half displacement. Am I right?
Right.
Yes.
So I can just take the xm. What is our xm here? Our xm is 2 millimeter. If you divide this value by 2, you will get the half of the displacement. Am I right?
Yes.
Right, teacher.
So I can just take K multiplied by xm over 2 is my amplitude half. Once you substitute the value right now, you will get the answer for the E part. Clear?
Clear.
It's a very easiest chapter, but first of all, you have to bring all the formulas here. You can just see how many formulas we are using in this question. It's all these formulas are interlinked with each other. Am I right?
Yes.
Yes, teacher, you're right.
Okay. Shall I go to the fourth question?
Doctor, I have a question.
Yes, please.
Doctor, why you don't put the minus before the constant?
My dear, I take the magnitude. If you want, you can just take no problem. But I take the magnitude. If you just put negative, the answer is also correct. My dear,
okay.
you will get the amplitude either positive or negative. Am I right? Both sides
Yes.
you have the amplitude. Am I right or not?
Yes.
So if you take positive, no problem. If you take negative, no problem. You will get the full mark. But
Yes.
generally force is the we will take the magnitude. Am I right?
Yes.
Because negative of force is a meaningless. Am I right or not?
Yes.
So that's what we
Yes.
take the magnitude. Clear?
Clear, Doctor.
Clear. Clear.
Okay. So answer is given here, my dear. It's my kind advice to each and everyone. Take a paper, solve the question, each and every question from this chapter. For sure, one question from this model. Okay. Okay. So this is our fourth question. It's a very easiest question. Please read one by one and give the answer. What is given in the question? A 5 kilogram object on the horizontal frictionless surface is attached to the spring. My dear, your question will be like this. Listen carefully. This is my horizontal and I have a spring. You have the mass connected to the frictionless surface. Clear? Clear?
Clear.
And then
Clear.
the spring has a K value. So the mass of the object is given. What is the mass of the object? 5 kilogram. And the spring constant of the spring, the value of the spring constant is given as 1000 Newton per meter. And the object is displaced from equilibrium horizontally. That means when you just drag, your spring will be coming like this. Am I right? Am I right?
Yes.
So what is this? This is my maximum displacement horizontal. Am I right or not?
Yes.
So my x value is given here. What is my x value? Better I can take x sum, x naught. So better I can take this is x naught for your easiest understanding. X naught is the maximum displacement of the spring horizontally. So that means 50 centimeter. So I can convert it to meter. Clear? And it gives an initial velocity. What is your initial velocity? Initial velocity is given as 10 meter per second towards the equilibrium position. That means it will be come back to the position when you just drag. Now, first question, what you are going to find? You are going to find the frequency. Second question, you are going to find potential energy. And the third question, you are going to find kinetic energy. And then fourth question, we are going to find what is your amplitude. Clear? Understand? Clear?
Yes. Yes.
Yes.
Okay. Let's we come for the first question. My dear, this question is related with the spring mass system. They clearly mention. So we have the time period formula. What is the formula for time period, my dear? My time period formula is, what is my time period? My time period formula is 2 pi square root of mass over k. Am I right?
Yes.
Yes.
So once you have the time period, you can easily find the frequency. What is the formula? 1 over t. Am I right?
Yes.
So take this t. So I can just write the first question answer. My frequency, which is equal to 1 over t. My t is already know. We know the formula 1 over 2 pi square root of mass over k. Am I right?
Yes.
Mass is given in
Yes,
the question. What is your mass? 5 kilogram. What is your spring constant? It's 1000. When you just substitute, you will get the answer for the first question. Am I right?
Yes, teacher, you are right.
Okay. Okay. Let's we come for the second question. What is the formula for potential energy, my dear? Just go back to the formula slides. What is your potential energy? This is my potential energy. My potential energy, which is equal to half k x square. Am I right?
Right.
So
Yes, teacher.
I can just write this rule here. My potential, which is equal to half k x naught square. Now you can see k value is given in the question, x naught value is given in the question. You can easily find the answer for the B part. Am I right?
Right.
Yes, teacher.
What's the unit, my dear? Joules, okay? Because potential all energy is in terms of joules. Now let's become for the third question. Kinetic energy. My dear, what is the formula for kinetic energy? Half mv square. Am I right? Mass is given in the question. Speed is given in the question. You can easily find the kinetic energy. Am I right?
Yes,
Yes.
teacher.
Yes.
Okay, that's it. Let's become for our last question. My dear, last question is very, very important. Please listen carefully. My dear, we are going to find the amplitude because here we find the potential energy and the kinetic energy. What is our energy equation, brother? What is our total energy? Total energy is nothing but the combination of potential energy and the kinetic energy. Am I right? So when you just find the value of D, my energy, which is equal to potential energy plus kinetic energy, but what they need only the XM. Am I right? Am I right or not?
Right. Yes.
Yes.
And we already know
Yes.
what is your energy formula, my dear. What is your energy formula? My energy formula is nothing but half k xm square. Am I right?
Yes.
Yes.
So here k value is given in the question. Xm we are going to find, but how to find this energy? When you just add this potential energy, when you add this kinetic energy, you will get the answer of E. Am I right?
Yes,
Yes.
So
teacher. You are
take the
right.
answer after you add this, take the value, substitute here, and once you substitute, you will get the value of the energy. But by using this, you can easily find your xm square. Therefore, xm square, which is nothing but 2 multiplied by E divided by
Okay.
K.
Okay.
So now, therefore, my xm, which is equal to square root of 2 multiplied by E over K. Am I right?
Right.
Yes.
So potential, that means the total energy we have the spring constant. When you substitute, you will get the answer for D part. Clear?
Yes, clear,
Clear.
teacher.
Any question from this? Do you have any question?
No, teacher.
Any other?
No, teacher. Thank you.
Any other? Okay, that's good. Okay, let's become for our last question. My dear, last question is very, very easy, but you must know the wave equation because here the wave equation is given. Let's we just read, and they clearly mention this question is related with, my dear, this question is related with simple pendulum.
Simple
When you
pendulum.
just go, when you come for the simple pendulum, we have the rule. Am I right? Just go back to the formula slide. What is your formula for the simple pendulum, my dear? The formula for the simple pendulum is T, which is equal to 2 pi over 2 pi multiplied by square root of L over G. What is your omega? My omega is square root of G over L. Am I right? So in this question, we are going to use this rule. Clear?
Yes,
Clear?
teacher. Yes.
Okay, let's become, but we must use the wave equation. What is your wave equation, my dear? Let's we just read what is given. Suppose that a simple pendulum consists of small 60-gram bob at the end of the cord of negligible mass. That means you have the pendulum, it has the length of the string at the bottom because you already did that experiment. Am I right? Simple pendulum experiment you already finished. Am I right? You can just see you attach one end of the string to the clamp and another end of the string is connected with a small bob because you used 4 bobs: brass bob, aluminum bob, plastic and wood. You used it. Do you remember that?
Yes,
Yes.
teacher. We remember
So
it.
Yes.
same
Yes.
picture
We
you can
remember.
same picture you can bring into your mind, and we are going to use that concept. So you have the bob mass. The mass of the bob is given, which is 60 gram. That means the mass of the bob is 60 gram. So if you convert the 60 gram to kilogram, 60 multiplied by 10 to the power of -3 kilogram, and then it produced the wave equation. My dear, here the wave equation is given in terms of theta. That means the displacement. Am I right? My dear, could you please recall the formula? Could you recall the wave equation? What is your wave equation? X, which is equal to xm. What's your wave equation? Okay, better I can write this equation first, and then I can write the wave equation. Then only you can easily understand. My dear, I'm going to write this equation here. What is the equation? Theta, which is equal to 0.0800. The unit is given as radian. Cosine of omega value. What is your omega value here? 4.43 multiplied by t plus angle, phase angle phi. Am I right? Now, could you please recall the wave equation? X, which is equal to xm cosine of omega t plus phi. Am I right? Am I right or not?
Yes, teacher, you are right.
Yes.
Now, my dear, listen carefully. What is your xm? My xm is 0.080. Am I right?
Yes,
What is my omega? My omega, which is nothing but 4.43. Am I right?
yes,
By using this, I am going to find the answer for the pendulum. My dear, what is the formula? My pendulum rule, omega, which is equal to square root of G over L. Am I right? Therefore,
yes,
my omega square, which is equal to G over L. Therefore, my length, which is equal to G over omega square. Am I right?
Yes.
What is the value of G?
9.8 meter per second.
What is the value of
Square.
omega?
4.43 square.
Because you can just compare. Here we already compared. My omega here exactly same like 4.43. So I have the value of G. I have the value of omega from the equation. When you substitute here, you will get the answer for the length of the pendulum. Am I right?
Yes.
Yes, teacher.
Okay. Now let's become for the second question. We are going to find the maximum kinetic energy. My dear, what is the formula for kinetic energy? Kinetic energy formula, which is equal to half mv square. Am I right?
Yes.
But if you want to find the value of this kinetic energy, you must need the speed. Am I right?
Yes.
But there is no information about the speed here in this question. Am I right or not?
Yes,
Yes.
But we have the maximum speed formula. What is the maximum speed formula? V is equal to omega multiplied by xm. Am I right?
Yes.
What is
yes.
my omega here? What is my omega here, my dear? What is my omega?
4.43.
4.43.
What is my amplitude?
0.080.
So when you substitute, you will get the answer of the speed. Am I right?
Yes,
Yes.
So take this V, substitute here. What is our mass? Mass is already given in the question, 60 gram. Am I right? When you substitute here, you will get the answer for this B part. Am I right or not?
yes, teacher.
Yes.
Yes.
That's it. Chapter is over for physics 1.
We
So my
finished
dear,
the physics, teacher, now.
we finished the physics 1 completely.
Alhamdulillah.
So my dear, I did my part. I did my part. As a teacher, I covered all the chapters. I didn't miss any question. Am I right? I work out all the question. Now all the informations are in your hand. Am I right?
Yes,
Yes,
doctor.
But the most important thing, you have to take the practice. I told you, my friend, listen carefully. From chapter 9 to 15, more weightage. From chapter 1 to 8, less weightage. It's my kind advice to each and everyone. When you just go for revise for your final exam, first finish from chapter 9 to 15 and then go for the previous chapters. And I already gave the formula slides. Am I right? I already gave the formula slides. Am I right or not?
yes, teacher.
So my
Yes,
dear,
yes.
now all the revision slides are in your hand. All the slides, theoretical, so that means the chapter slides with the problem, and also you have the recorded video. So everything you have in your hand. But the most important thing, keeping everything in your hand is not good. But the most important thing, you have to take a practice. Okay, just keeping in your hand will never work. The most important thing, you have to take the paper, you have to work out. If you have any doubts, go and see the video. And even if you don't understand anything from the video, please contact me through WhatsApp group. I will help you. Clear?
Clear, yes, teacher.
Clear, my dear?
Yes.
So
teacher.
I just did my part. I hope everybody should do your final exam good. And inshallah, I would like to see you in physics too.
Inshallah.
Inshallah.
Clear? So it is very easy. My dear,
Teacher,
yes.
I want to see the answers for the last question, 62.
You want to see the last? You mean this question? Okay, just a minute.
Yes, yes.
See here.
Yes. Wait a minute. You will tell
You
me.
can see, my dear, here. Xm is not given, but xm value we have to use in terms of length, because length we already find. Am I right? My dear, we
Yes,
already
we
used
find
this
it.
concept. Better. I can just use for the paper, practical paper.
Yes, we have used it. Yes.
We already used the arc length formula. Am I right? When you just
Yes,
use
and
this, you can get
in
the answer, because
experiment.
especially xm is nothing but length multiplied by theta m. Am I right? Because the theta m value is given in terms of amplitude. Am I right? So you have to substitute the value here to get the answer. Understand?
Yes, I understand now.
Dear, any other question from your side? The most important thing here, I forget. Yes,
Teacher,
here I
thank you.
forget. Here I forget to write with a L. My dear, listen carefully. Sorry, because V, which is equal to, because here this is xm, but this is our theta m. Am I right or not? Because this theta means this is theta m. Am I right? Am I right or not?
Yes.
So what is
Yes,
our
you are
theta
right.
m, my dear? Xm, which is equal to length multiplied by theta m. We already studied this formula. What is this formula, my dear? The relation connecting linear displacement and angular displacement. Am I right? So we already have the L value. When you substitute, you will get the answer here as V, which is equal to my length multiplied by my theta m. So you will get the speed multiplied by omega. You can just take the value and substitute here. Clear?
Yes.
Yes, teacher.
Is there discussion class tomorrow?
Yes, my dear. Could you please repeat again?
Is there discussion class tomorrow?
My dear, discussion class will be there.